And in this topic, we will explore faulting, which involves the fracture and displacement of rock layers in the earth crust due to tectonic forces. Faults occur when the stress on rocks exceeds their internal strength, causing them to break and move. Faulting is a fundamental process in shaping the Earth's surface and plays a key role in earthquake activity. And understanding faulting is essential for geologists to interpret the Earth's structural features, assess seismic hazards, and explore natural resources. We have the image of a fault, and we have the three main types of fault. We have the normal, reverse fault, and the strike slip fault. We have the objectives. By the end of the topic, we should be able to define and explain faulting, identify and describe types of fault, analyze fault structures, understand the causing of faulting, and evaluate the implications of faulting. Welcome back. We are now going to discuss about the faulting in details, and we say that faults are fractures or cracks that develop in the crust. When tensional forces cause crust rock to stretch and fracture at the region of maximum tension, or when compression causes squeezing of crust rocks to fracture at the areas where they are intensely squeezed. Faulting also occurs when vertical movement exert pressure on rocks leading to fracture, or when shear forces cause crust rocks to tear. You have the parts of a fault. Here is the upthrow, you have the downthrow, you have the fault line at this region, you have the fault plane, you have the throw, you have the head, and the hip. Then we come to discuss about the types of faults. Number one is the normal faults. This is the type of fault that is formed by tensional forces in which one block slides downward in relation to the other, and rocks are subjected to tensional forces. So when these rocks are subjected to tensional forces, a crack occurs here at the middle now, and this a normal fault starts to develop, and this pad sinks downward, and one block slides downward. When one block slides downward, we have the image here, leading to formation of a normal fault. A reverse fault, this is a type of fault that is formed by compressional forces in which one block of land is pushed upwards in relation to the other. We have rocks are subjected to compressional forces. When these rocks are subjected to compression, this is the first step. Rocks are subjected to compressional forces and a reverse fault develop. This is a reverse fault, and one block is pushed over the other. When one block is pushed over the other, the image occurs is like this. Then we have shear or tear fault. They are formed by shear forces in which adjacent blocks of landslide pass one another. If a shear fault occurs between continents, it is called a transform fault. For example, San Andreas Fault of California and Great Plains Fault of Scotland. And these are the two rock masses slide against each other and leading to formation of a transform fault. We have the thrust fault. Uh, type This is a type of fault that is formed when very strong compressional forces cause almost horizontal force to develop and one block of land is pushed over the other. So this is the one block of the land and it is pushed over the other. You have the anticlinal fault, and here is the image. You have the faults, you have the anticline, and here are the faults. And they are formed when anticlines are compressed further and cracks form on the crest. So when these anticlines are compressed further, the cracks occurs on these regions. We have features resulting from faulting. Number one is the fault scarp, or we call the escarpment. This is the escarpment. This is up through the down through, leading to formation of an escarpment at this region. And here is the image of here is the picture of the Rift Valley escarpment in Kenya. Steep line of slopes formed by vertical movement of earth along a fault, e.g. Mau, Burma, Nyandarua, and Nandi, are exposed parts of the fault plane. It may be formed due to normal faulting or reverse faulting when overhanging blocks are eroded. An escarpment is a result of faulting. You have the fault steps. These are land resembling the staircase or steps of a house with a series of fault scarps at different levels. Parallel vertical faults develop, and land between the faults is unequally displaced downwards, and a series of fault scarps at different levels is formed. We have the parallel faults, and it resembles a staircase of a house. We have the faults at this place. One examples of this fault steps occurs in Keyo escarpment at Kijap. You have the fault blocks or blocks or what we call the host mountains. They are the blocks of land raised above the surrounding land. This is the fault block, and the land is raised above the surrounding land surface. It occurs where tectonic forces cause faulting and land on one side of the fault get raised or sink along the fault planes. The examples of fault blocks are Aberdare, Nyandarua Ranges, Mau Escarpment, and Nandi Hills. We have blocks of land bordered by normal faults which are almost parallel to each other sink, leaving the middle block standing. Examples of faults are Rwenzori of West Uganda and Usambara and Pare Mountains of Tanzania. You have the forces of uplift and a fault as occurs and this part of landmass sinks, leading to formation of a block mountain or what we call the host, as depicted by the diagram. We have tilt blocks, fault blocks which are inclined on one side. The tilt blocks are fault blocks which are inclined on one side and occurs when the fault block, host, or fault step have greater uplift on one side, a greater uplift on this, there is a greater uplift on this side, and as a result, there are no flat at the top but tilted. So this top part becomes tilted. The resultant features are tilted fault blocks, tilted host, and tilt fault steps, which forms ridges and faults guided valleys. And we have the tilted host, we have the fault here, and there is a greater uplift from this region, leading to a tilted host. When there is a greater uplift on the fault scarp, this region is tilted upwards. Then we have the Rift Valley and a long narrow trough with steep escarpment on both sides. This Rift Valley is a long narrow trough with steep escarpment on both sides. You have the theories of formation. You have one is the tensional theory, and it said that rocks are subjected to tensional forces. For example, this landmass is subjected to tensional forces going to this side, going to this section, and normal faults which are almost parallel develop. Now, normal faults start to develop on this part and this part, and they are almost parallel. One block slides downward, forming the rift valley. So when one block, that is the middle block, slides downward, it forms the rift valley, and this region is the escarpment. You have the compressional theory. Rocks are subjected to compressional forces, and uh, this landmass is subjected to compressional forces. The force is going this side and this side, and a reverse fold, which are almost parallel, develop. Here is the reverse fold, and reverse fold develops here. The side blocks are pushed over the middle block. So these side blocks are pushed like over this middle block, leading to formation of the Rift Valley. Overhanging blocks are worn out by the nutation to form escarpments. You have the escarpment, you have the Rift Valley, and when the of hanging blocks are worn out by the erosion to form escarpment. So escarpment forms here and making this side as Rift Valley. We have anticlinal theory or anticlinal theory. It suggests that the Rift Valley was formed by anticlinal arcing and upward forces pushed the sedimentary rocks strata upwards. The rock layers bent into a big arch, and a gaping huge crack developed at the crest of the arc due to tensional forming the Rift Valley, as depicted by this image. There is a crack here forming the Rift Valley. The Great Rift Valley or the Great East African Rift Valley. The world's biggest rift valley. It is the world's biggest rift valley and it starts in Syria and ends in Mozambique. It is divided into four parts, that is the Ethiopian Rift Valley system starts from Afar in Ethiopia to the Kenyan border around Lake Stephanie. We have the Gregory Rift system. It starts from the northern border of Kenya with Ethiopia to Tanzania. It has a small northeast to southwest branches. Kano Rift Valley in Kenya and Lake Eyasi Rift Valley in Tanzania. We have the Western Rift Valley that at Sudan border to south of Lake Rukwa and features which are here are Wensori Mountain and Lake Albert, Edward, Kivu, Tanganyika and Rukwa. We have the Malawi Rift Valley, a continuation of the Gregory Rift system to Zambezi River in Mozambique. The Gregory Rift Valley it is named after the geologist called Gregory J.W. who carried out extensive studies in this area. It's where the Rift Valley features are more pronounced. Features associated with it we have the fault blocks, for example, Chabadea Range, the Mau, Nandi, and Tenangaji Hills. We have the steep faults, for example, Kijabe and Taupaj. Deep blocks, Abadea Range, uplifted and tilted east-west, and Mau Escarpment, uplifted and tilted westwards. Lava flows and volcanic cones, Ichi, Menengai, and Gorongoro crater. Rift Valley lakes formed when unequal sinking crater faults, which are later filled with water. For example, the lakes are deeper and elongated. Examples are Lake Naivasha, Nakuru, Elementaita, Baringo, Bogoria, Olbolosat, and Turkana. Most of the lakes are salty, with exception of Lake Naivasha, which has fresh water. And we have a question here: why most Rift Valley lakes are salty? Number one is that it lack of outlets to drain away salts contained in them. Number two is lack of enough water to dilute salinity due to little rainfall and lack of rivers flowing in them. We have the high rates of evaporation causing increased accumulation of salts and lakes water being in contact with rock with mineral salts which it directly dissolves, washing into the lake of mineral-rich soils by surface runoff. And we have a question that says that why Lake Naivasha has fresh water. Number one is that it has underground drainage to the Indian Ocean, and there is inflow of fresh water from rivers and rain. The latest volcanic eruption covered the bedrock with lava, and major faulted areas of the world. The Great Rift Valley from Syria to Mozambique. We have major folded areas of the world. Number one is the Great Rift Valley from Syria to Mozambique, northern England, and the Great Glen Fold of Scotland, the Central Massif of Europe, and the Middle Rhine Rift Valley regions. We have the significance of folding companies to human activities. Rift Valley lakes are important for fishing, irrigation, and domestic use. The Rift Valley and associated features are a tourist attraction which earns foreign exchange. Hot springs and geysers formed during folding can be harnessed for geothermal power. Block mountains are water catchment areas and sources of rivers due to heavy rainfall they receive on the windward side. Faulting results in the exposure of minerals such as diatomite in Kilgit and feldspar in Keria Valley. Fault scarps may expose underground water, resulting in the formation of scarp springs. Unequal subsidence caused by faulting may cause formation of depression, which may form lakes which useful for fishing, transport, and mining, e.g. Lake Naivasha. We have the negative impacts of faulting. Number one is that faulting disrupts transport and communication by disjointing land. And number two is that faulting may lead to loss of life and property by causing land to sink. Faulting may cause a river to disappear or change its course and flow along the fault line. Steep scarps formed by faulting are prone to soil erosion. Faulting has given rise to semi-desert conditions in some areas where mountains or paths of rain winds cause riverside to receive little, little rainfall. Thank you.